Hi, guys. All right. We're going to be working on engine basics. Uh, it's normally I would have you guys like go into the engines lab and actually take an engine apart a little bit, and so you can see all these pieces and hold them in your hand. But since we don't have that, all I got is pictures. Uh, so here, let's rock and roll. Engine basics. We have a four-stroke cycle, gasoline fired, liquid cooled. There is air fired. We also have diesel. We have CNG, compressed natural gas. But we are talking about an internal combustion engine, something that deals with, exploding some type of fuel to power the pistons. So let's, walk through this real fast. Some parts that we have that are common amongst all engines. We have a piston moves up and down inside the bore. We have, valves that let the air and fuel in a lot of instances into the cylinder. We have a crankshaft that rotates, and we have an exhaust valve that lets the spent exhaust gases and pressures out of the cylinder. There's a lot of different configurations, but this is by far the most common. Well, I don't know about most common anymore. We have this particular one is a cam in the block. We've looked at cams. You measured the lift on a cam. We talked about some of the stuff. But this cam rotates, and that pushes on a lifter, which pushes on a push rod, that pushes on a rocker arm. And then the rocker arm, it's kind of like a little hammerhead. It pushes down on the valve itself, and that's what, is how the valve opens and closes. There's different types. We have Hemi heads. We have L heads. That's really not used anymore in an automotive environment. Emissions, and gas mileage too, but still utilized in lawnmowers. Your basic lawnmower engine is an L head engine. I'm going to put up a link to a whole bunch of animated engines. I encourage you to poke around inside there. There's some interesting engine configurations. I'll post up a link. Four-stroke cycle is probably the most common, also known as the Ott cycle, named after an old dead guy. His name was Ott. And every cylinder completes this, and it's the intake stroke, the compression stroke, the power stroke, and the exhaust stroke. And it needs to complete them in that order. And we'll get more into this. Intake stroke. The piston's moving down inside the cylinder bore. The crankshaft is spinning, and that's pulling the piston down. This creates a void, a slight vacuum inside the cylinder. And when we open up this intake valve, it causes a low pressure system to draw in air into the cylinder. A lot of times this is accompanied with fuel. Modern engines, very modern engines, use direct fuel injection, which means the fuel is not traveling in with the incoming air. And this takes 180 degrees of crankshaft rotation. We talk a lot about degrees of crankshaft rotation. More of that is covered in, the 232 class and the 125 class, but realize we talk in terms of degrees of crankshaft revolution. We can't talk about time, because as RPM speeds up, the piston moves faster, crankshaft moves faster. So we talk about degrees of crankshaft rotation, which is relative to time, but as engine RPM speeds up, we can't use time. But there are things that are fixed in the time they take to do. And we'll talk about that in a second. The compression stroke. This is another 180 degrees of crankshaft rotation. So the crankshaft has rotated, 180 degrees and 180 degrees. So it's gone, around one time. This is one crankshaft revolution with the intake stroke and the compression stroke. Now, piston's moving in an upwards direction, and both valves are closed, so we've sealed the cylinder off. The air-fuel ratio is compressed. When we compress this air-fuel mixture, it does two things. It heats it up, and it helps mix it. It helps the fuel vaporize inside the cylinder. We need good vaporization so that we have a good fire. Which brings us to our next one is the power stroke. Now, we light off the mixture, the spark plug or the glow plug, or just compression ignition in terms of the diesel. But we light the air-fuel ratio, the air and fuel mixture in the cylinder gets lit off. Now, this combustion event can get very complicated. As a matter of fact, we cover this in 232 in great agonizing detail. This microsecond or several microseconds of ignition spark is extremely important. We need spark. It needs to be the right amount of time, duration of the spark, duration of the spark. It also needs to be, at exactly the right time. And we'll talk about that in just a second. But realize this ignition sequence that happens causes the piston to move down due to the hot expanding explosion up above the piston. Now, it gets a little complicated. I'd like to cover that.